Hi, today we're going to look at the first question. It's based on the maximum number of distinct elements after an operation. So what this question is asking for is that you will be given an array of nums and you can carry out a particular operation. In this operation, you will try to change the value in the num so that you will get a distinct value. So the value that you can minus off is in the range of k. So the k is between negative k and k, inclusive of the k value. So you can choose any value between negative k and k, and you can minus. You can technically add the value or remove the value from nums I, and by doing so, your aim is actually to obtain a distinct value. So now let's look at the example. The first example is was given. Here you can see you're given nums. The array is shown here, and based on that, you can see there's two similar or non-distinct integer giving in the array of nums. You're also given the value of k, so as 2. So basically you can add -2, -1, 0, 1 or 2 to the numbers given here, and the aim is to actually obtain the unique number. Based on this, you can see the change nums is -1, 0, 1, 2, 3, 4. This is the change value, and you can see that based on the change value, you now have 6 distinct values, which is unique. So the first thought will go to creating the brute force way. The brute force way is actually to have a dictionary, and in this dictionary you will have like a nums. The nums will actually will be tracked. For example, you have the first num as 1, and now you move to 2. You check what is the next value that's not inside this dictionary, and it's 2, and you can put the value of 2. Then you go to 2, and you see that if you try to put the value of 2, it start to clash with the dictionary that you have. So you look at the k value that you can use. You can use -2. You want to put 0 to it. So you have 0. You also can choose a value of 1, which means that you have 3, or you also can choose a value of 2, which is 4, that is not inside this dictionary. So if you do this brute force operation, what will happen is that you know that the array length is 1 to the 10 to the 5. This is the length of the array, and you have also the k value, and the k value can be anything between 1 to the 10 of power of 9. And if you do this operation, right, for every elements in array nums, you do the k value, where we try to add a k value, and then you check in the dictionary whether the num is inside the dictionary. Then the base case solution will be actually k times l. If k times l, then what will happen is that your solution time will be 1 to the power of 14, and this is not acceptable. Okay, in Leetcode, what is acceptable solution are normally 1 to the power 10 power of 9. Alright, so you have to find a solution with this, and brute force will not work. So what can we do? So the aim here is actually to have a distinct array or distinct number of array that you can track easily. So you want to use just a previous number, then you want to try to use the previous number and create a new number that is unique or larger. Anything that's larger than the previous number, you want to make it as unique. So as long as you start from the lowest possible value, and then you keep finding the next lowest value that is just bigger than the previous value, you will get a unique number. So this is a greedy approach in order to solve that. why we always take the lowest number. So when you take the lowest number, you are ensuring that the next number in the array will have the most option. Okay, for this case of example, let's say we take the value of 1. If you do this operation where you minus 2 minus 1 to 1, what you get is you get minus 1, 0, 1, 2 and 3. These are all the possible options that you will get when you apply the k values. And why do you choose 1? When you choose 1, what will happen is that, let's say you choose 1, negative 1, you will have the next number. The next number is 2, right? 2 will have the option of 0, 1, 2, 3 and 4, right? If you apply this operation, negative 2 becomes 0, then negative 1 become 1, 0. So in this case, when you took the previous value of negative 1, you ensures that you have the most option here, because negative 1 is haven't chosen before and you do not have that option. But in the first example, where if you choose not negative 1 but you choose like 1 here, and then the second number will have limited choice, because now you only, this option already gone already. Okay, you only have 2, 3 and 4. So this will have a rolling effect, and when you choose not the lowest value, and the next value in the array will have a lower option to choose from. And by doing so, what will happen that you will not get the most distinct values. Of course, you can also take 0, the value of for example 2 here, and you will also have the same problem later on when you try to create another value for 2 here, but then the 2 here now will have low limit action. See, if you take the second value of 2, since you take the value of 4 here, what will happen is that this value already is no longer an option. You can take the value 1, because 1 is not chosen, right? Because you choose negative 1, and then you choose the value of 2, but then you have 0 and 1 available. But in this case, what we're trying to do, we're not trying to use a dictionary and keep checking the value. So when you have a previous value, you just depending on this previous value to find the next value. So when you are doing so, you always want to choose the smallest value, in order that you do not have to look through the dictionary and keep checking whether this value is in the dictionary. Instead, just using the previous value to determine what is the next value. And if you choose the lowest value, you will always have the largest option available for the next number. That's the greedy approach. That's a basic greedy approach in order to solve this problem. So let's look at this solution. So first, if you have to sort the numbers so that it always go from lowest to highest. Then you're going to initialize the values. So you're going to initialize two variable, answer and also the previous. The previous will going to be none, so that because you will start from 0, and then you will start from index 0, so you do not have previous. So in the first case, when the previous is none, you just gonna take the smallest value. So you're gonna take that value nums I, and you are gonna minus the value k. This will be the starting point, which will be the smallest value, and you're gonna have a one distinct value, so your answer will be added as 1. Next, in the case where the index is not 0, you're gonna have you're trying to find the mean val, so you minus k, and you're also trying to find the max val. The max val you're adding k. So in the first case, if the previous value is smaller than mean val will be the next smallest value. Okay, and you add 1 to the answer. And in the case that previous is actually bigger than mean val, but then it's still smaller than the max val, you actually can add 1 to the previous value. So you're adding 1 to ensure that is the smallest possible next value that is larger than the previous value. So you add 1 here and you're adding answer 1. And then what you're doing is that after that you will look through all the array, you're just returning the answer. So if you solve this, you will see that you will get the answer, and the answer is solution is at 702 millisecond, and yeah, it's quite fast. And that's for it.